Right, section 5.1, we're going to be talking about the characteristics of parabolas. So some of the characteristics are marked right here. You can see the lowest point on this particular graph is the vertex. If this was a positive, you'd be looking at a maximum, and that's also at the vertex. The vertex, the x value of this is what's called the axis of symmetry. So that's where if you cut the parabola in half, you could fold it on itself and it would be identical. So you can see if you were to fold this in half, it would line up perfectly with the opposite side. So that's the axis of symmetry. And then you have the x-intercepts. So that's anywhere the parabola crosses the x-axis. In this case, this one crosses twice. You'll see a slide a little bit later. Actually, I can pop you to it right now. You have a couple different situations right here. So here you would have no x-intercepts at all because the parabola is above the x-axis. In this case, you would have one x-intercept because it comes and touches the axis and goes back up again. And then in this case, you would have two x-intercepts because it actually completely overlaps the x-axis. So those are the three situations that you'll have. And then the last one is the y-intercept. So that's the point where the parabola crosses the y-axis right there. So looking at this next one, we can identify these characteristics just by looking at the graph. So you can see we've got our axis of symmetry at x equals 3. And then we also have our vertex at this point. So our vertex is going to be at 3, 1. And then we don't have any x-intercepts in this case because it's above the x-axis, but we do have a y-intercept, and that is at 7. So our y-intercept is at 0, 7. Here's another example. You can see the axis of symmetry, and that occurs when x equals -2. Our vertex is going to be -2, and our y value is also -2. We have x-intercepts, and those are at -1, 0, and -3, 0. And then we have our y-intercept at 0, +3. So let's take a second to just check this out. So the y-intercepts are usually pretty easy to see from the equation because if you plugged in a 0 for the x's, all you'd be left with is this part. You can also rewrite this in in vertex form. So let's do that, and then that will help you clearly see where the vertex is coming from. You can also factor this one. So if we had to factor, that would give us x + 1 and x + 3. So x equals -1 or -3. So you can see here we've got those. And then let's rewrite it into vertex form. So we've got our a, which is just 1. It's ax squared plus bx plus c. So our a in this case is 1, our b is 4, and our c is 3. So we've got a equals 1. So we're just going to have f of x equals x, and then we're going to be minus h. Our vertex is hk. So we've got x minus h. Well, our h is -2, so that means we're going to have a +2, and that's squared. And then our k is -2. So our equation in, did I write this right? Sorry, yeah, I did this wrong the whole time. -2 should have been -1 here. So sorry about that, guys. So that should be a -1. So this is going to be -1. I think that's the only thing it changed. There we go. And then so now you can also, if you wanted to pick out the vertex from here, you would see that this is going to be a -2 and a -1 because this is our h and this is our k. But just be careful here. Maybe sometimes it helps to assume this is the negative h. And then I think we've got it all. And here's another example. You can see in this case we have a negative coefficient. Our a is negative. So when a is less than 0, we have a parabola that opens downward. If a is greater than 0, then we have a parabola that opens upward. These are increasing to positive infinity, and this is going to negative infinity. So now let's go ahead and pull out the vertex from this formula. So remember, this was negative h, so that means our h equals negative 2, and our k equals 4. So that's going to be negative 2, 4 is the vertex. And we can confirm that. Go to negative 2 and up to 4, there's our vertex. And then let's see what our y-intercept is. So if we set this equal to 0, this is a little bit harder to find your y-intercept versus it being in quadratic form or standard form. This one you have to do a little bit more math. So we've got 0 here, which means we're going to have 2 squared, so it's 4, times the negative 3, so it's going to be negative 12, plus 4, so it's going to be negative 8. So our y-intercept is at negative 8, and that definitely is consistent with what we're seeing on the graph. Now the next part is the x-intercepts. These do not look nice. So we've got a couple of choices here. We can, in this one in particular, we're only looking for the vertex. So I'm going to stop. We do have some trickier ones that we'll get to later on finding these x-intercepts. But what you'll want to do is just either set this equal to 0 and solve for x, or rewrite this into quadratic form and solve for x. So we'll do that on another one coming up. This is your toolkit function. So all of these are going to be some sort of modification of this. So x squared, we have no bx and no c. It's just the simple y equals x squared value. So now let's take that one and then let's translate it here. So if we had f of x equals x squared, what have we done? On the inside, we've shifted it left 2. So that's going to say plus 2. And then we've shifted down 3. So that's going to say minus 3. So that's our new function. This one, I'm going to kind of skip. This one wants you to rewrite it as an equation. We can do a quick check and see what's going on here. So here's your axis of symmetry. Can't quite tell, but here's your x-axis right here. We've got a point right here, and then it looks like we have another nice point right about here. So that's 1, 2, 3, 4 down and 3 over. So 4 down and 3 over, it's going to hit right here. So the question was whether or not you're going to make the basket. I would say no. It looks like you're going to hit the rim. But this is an example of, parabolas in real life. And some of the next characteristics we're going to be looking at are maximums and minimums. These are the most beneficial things, in my opinion, when it comes to parabolas, because there's going to be lots of situations where you're going to want to know how to maximize or minimize your output. Should say max, sorry about that. So you can see in this particular case, it happens at the vertex. So our vertex here is negative 3, 4, and you can see that right here. So your h value is negative 3, and your k value is 4. So there's your vertex for that one, and it's going to be a maximum. The maximum value of 4, and that occurs when x equals negative 3. And then in this one, it's a minimum because it's the lowest point on the parabola. And you can see again from the equation, we've got 2, 1. So our minimum value of 1 occurs when x equals 2. And here is a real life example of when you could use this. So let's say we're setting up a fenced-in garden. We don't want all the deer to eat our plants. I've given up. But we've got 80 feet of fencing that we can use to enclose our garden. In this case, it makes sense to maximize the area, right? We've got this huge backyard. We want to set up a nice big garden. So what are the dimensions that this should be for us to be able to maximize the amount of area? Well, we don't know these dimensions, but we do know that we have 80 feet. And we know that the perimeter equals 2 times length plus 2 times the width. And the perimeter is 80. So that's going to tell us that our width is going to equal 80 minus 2L. You know, in this example, it doesn't tell you, but we only need the 3. We only need the 3 sides. Yeah, it doesn't tell you in the example, but we only need the 3 sides. So actually this should be just 1W. We have 1W and then we have the 2 L's on the side. And those all added together are going to equal 80 feet. So that gives us W equals 80 minus 2L. So now we've got our area, which equals the length times the width. And we want to know what the maximum of this is. So that tells us that we have L times 80 minus 2L. That's going to give us L negative 2L squared plus 80L. And now we want the vertex. So H, I don't know if you've seen this formula before, but H equals negative B over 2A. So we've got our formula here. Our A is negative 2, and our B is 80, and we don't have a C. So that's no problem because we're not talking about a C in this case. So it's going to give us a vertex at 20. So when L equals 20, the width is going to be 80 minus 2 times L. So it's going to be 40. And then what is that area? That's going to be 40 times 20, or 800. So we're going to be able to get a maximum of 800 square feet if we have the lengths at 20 and the width at 40. Let me see what we're doing here. So this is a parabola of what we just did. So here you can see we reach our maximum of 800 when the length equals 20. And here's a real world example of newspaper pricing. So the word problem says that right now it's at $30 per quarter for the newspaper, and they have 84,000 subscribers. And they want to know, they know that if they raise it to $32 per quarter, they're going to lose 5,000 subscribers. So somewhere between 84,000 and 89,000 is a maximum. So they want to know what the perfect price is to have the most subscribers. I was trying to see if I had this equation on there somewhere. But so we can find the axis of symmetry here. And that is our maximum point right there. And that point is going to be at about $31.80. $31.80 would result in the most subscribers. Here's back to the different situations that we're going to come across with intercepts, none, 1, or 2. And here is another example of how to go about finding those values. So in this case, we're focusing more on just the intercepts. So the easiest one to me is the y-intercept, because you just plug in 0 for these and you find out what's left. So negative 2 is what's left. So there's our negative 2, our intercept. And then x's are a little bit trickier. So depending on whether or not the function is factorable, we can try to factor it. You can plug it straight into the quadratic formula, or you can rewrite it in vertex form and then solve it from there, whichever you think would be easier. In this case, it looks like it's factorable, so I'm going to go ahead and try it. I've done this before. I don't know if you guys have seen this, where you're going to multiply these two factors and then finish factoring it from there. So 3 times negative 2 is going to give me a negative 6, and I need that to make a positive 5. So I'm thinking 6 and 1, it's going to give me a positive 6 and a negative 1. And then the tricky part is figuring out where the 3 goes. Well, 3 and 6 are factorable, so it's going to go with the 1 instead. So we've got 3x minus 1 and x plus 6. Sorry, x plus 2, because if we factored out the 3, that would leave a 2 here. So we've got x plus 2. So we've got x equals negative 2 and x equals positive 1/3. So you can see those right here, positive 1/3 and negative 2. And here's another one that is definitely ugly. So this one, we can use the quadratic formula, or we can rewrite it as in vertex form. So this function, the word problem actually gives you the equation, and that's 2x squared plus 4x minus 4. So you can see this looks pretty nice. I would say let's try to factor that. If we factor out a 2, that's going to leave us with x squared plus 2x minus 2. Not nice. Never mind that one. So let's go ahead and turn this into vertex form. So that's going to be 2x minus h squared plus k. So we can substitute our values here. We've got our vertex that we can use right here, and that point is at negative 1, negative 6. So we'll take these values and we'll throw them into this equation right here. We took our a from this part. So if you remember, it's a x minus h squared plus k. So we took our a from here, plugged it in, and then we just rewrote the equation the way it was. So let's rewrite this with our vertex in it. So that's x minus h. H is negative 1, so it's going to become positive 1 squared, and then it's a minus 6. So now we can go ahead and solve. We can finish factoring. So if we set this equal to 0, that's going to give us 2 times x plus 1 squared equals 6. Divide by 2. That's going to give us x plus 1 equals plus or minus the square root of 3. And x equals negative 1 plus or minus square root of 3. And then we want to go ahead and simplify because I can't tell where that is on the number line. So this is one of those rare cases where go ahead and get the decimal. Go ahead and figure out what this is. So that's going to give us x equals 0.732 or x equals negative 2.732. So you can see those are our x-intercepts right here. And the last one, here we're talking about a word problem. I think this is the height of a ball, and it wants to know what the maximum is. So they've already got that one marked out for us. Our maximum height is 140 feet, and that occurs at 2.5 seconds. Now we want to know what our x-intercept is. It looks nice. I don't think it's quite as nice as it looks. So let's go ahead and finish solving this. So again, you can do one of two things. You can rewrite this into vertex form, which is, I think, my preference, or you can use the quadratic formula on it. Either way, you're going to end up with the same kind of answer. So I'm going to rewrite this in vertex form. That's going to give us negative 16 times x minus our h value, which is 2.5 squared plus 140. And now we'll set it equal to 0 again. And that's going to give us 8.75. So now we've got x minus 2.5 equals plus or minus the square root of 8.75, which is 2.5 plus or minus that. And that's going to give us two answers, either 5.458 or negative 0.458. this is when I would like you to consider the question at hand. So it's talking about height at a certain time. So negative is not going to make sense. So we only want our positive value. So this actual number occurs at approximately 5.458 seconds. That's when the ball will hit the ground, aka that is our x-intercept. And that's it for this section.